So this will be the answer key to the multiple choice part of your 5.1 to 5.3 quiz. So to start off, number 1, this was a inconsistent interval where you were asked to do a Riemann sum, but it was supposed to be a right-sided Riemann sum. So first you got to figure out how wide your intervals are. So that we do by going from 5 to 6, that's 1 wide. From 6 to 9, it's 3 wide. From 9 to 11, it's 2 wide. And from 11 to 12, it's 1 wide. So that's how wide the intervals are. And the heights, if you look at between the first interval from 5 to 6, the 10 would have been if you're doing an LRAM. We're doing an RRAM. So the value for the first rectangle would be 7, so that's rectangle 1. 11 would be rectangle 2. This would be rectangle 3, and this would be rectangle 4. So, Riemann sum, integral from 5 to 12 of f of x dx would be a height of 1, a width of 1, a height of 7, plus a width of 3, and a height of 11, plus a width of 2, height of 12, and then plus a width of 1 times the height of 8. So you'll see up top, your x's always give you your widths, your y's always give you the height of the rectangles. That would be 7 plus 33 plus 24 plus 8. And hopefully if I can add, we get 40 here. We get 34. So hopefully we get 70. Oh, I can't add. Let's see. Double check that. And then this is 32. That would make more sense, and then the answer is obviously 72. So that's number 1. Number 2, a particle moves with the velocity. If the particle is at, so this is some type of initial, and in this case it said it's a position. What is the position of the particle at time equal to 1? So to find the position of the particle at time equal to 1, I would need an initial position plus the integral from the initial to where we want to find it of v of t dt. So we get s sub 0 was 2 plus the integral. So antiderivative of the velocity would be t cubed plus 3t squared. F of 1 would be 4. F of 0 would be 0. So I get 2 plus 4 minus 0. Therefore, the answer we get is 6. Number 3. So this one, we talked about if there is a rule to do the derivative, meaning if I wanted to take the derivative of this function, I would need a quotient rule. We don't know any quotient rules for integrals, so that means it must simplify. So the bottom of the fraction, x squared, is considered a common denominator because it belongs to x and it belongs to 4. So there's my simplified version. Then I'm going to simplify a little bit more, and I'll get x over x squared minus 4, and I'm going to write this as a power, x to the negative 2. So to find the antiderivative, the function 1 over x always confuses people. So we think of it as x to the negative 1. You always want to add 1 to the power, which would give us 0, and divide by that new power, 0. And that makes no sense. I want you to think about that because it means it must be someone's derivative because that power rule doesn't work. So if you think about it, the derivative of ln of x is 1 over x. Therefore, ln of x is the beginning. And then this guy, we're going to add 1 to the power, which would get it to be a negative 1. And then we're going to divide by the negative 1. So what does that give us? It gives us positive 4x to the negative 1 power. I'm going to rewrite that because I'm going to evaluate that. And I don't like negative powers when I'm evaluating. So then I find f of 2, which would be ln of 2 plus 4 divided by 2. F of 1 would be ln of 1 plus 4 divided by 1, which is 4. Ln of 1 is 0. So we end up with, going this way, f of 2 minus f of 1. F of 2 is ln of 2 plus 2. And f of 1 is 4. There we go. ln of 2 minus 2, which would be b. Average value. So that's a formula. That's something memorized. The average value of a function is 1 over b minus a from a to b of root of x dx. So in this case, it would be 2 minus 0, the integral from 0 to 2 of root of x dx. So over to the right, I'm going to find my antiderivative of x to the 1/2. So add 1 to the power, which would be 3/2, divide by 3/2, which is the same as multiplying by 2/3. I'm going to find this of 2. I'm going to find it also at 0. Antiderivative at 2 would be 2/3 times 2 to the 3/2, which would be 2/3 times 8 to the 1/2 power. Same exact thing as 8 is under a square root. And actually, while we're there, the square root of 8 is the same as 2/3 times 2, root 3. F of 0 is just 0. So what do we get? We get 1/2 times f of 2 is 4 root 3 over 3. Oh, that's supposed to be a 2. Sorry about that. Let me fix this for you. Let's go back over here one more time just to make sure that you are not confused. So let's go back to root of 8. Root of 8 is the same as 2 root 2, obviously, because that's 4 times 2. The square root of 4 is 2 on the outside. That leaves you a square root of 2 on the inside. So 1/2 times 4 root 2 over 3 minus 0. The minus 0 is doing nothing right there. And so I'm going to cross cancel. 4 divided by 2 leaves us a 2, and your answer is 2 root 2 over 3, which is C. A lot of people have been asking this problem. We did one in class together, and then I think someone asked that same question again a few days later. So, again, I said when you're looking at something you don't understand, look at the part that you do understand. You know how to do a definite integral. So, given that definite integral, I'm going to find the antiderivative. Add 1 to the power, divide by that power. Add 1 to the power, that would be x to the 1, divide by that power. So the antiderivative gives us 1/8 x to the 8th plus kx. Then you're asked to find f of 2, which would be 2 to the 8th divided by 8 plus 2k. F of negative 2 would be negative 2 to the 8th over 8 minus 2k. So how did I get that? Remember, you're taking your k is still there. There's the k. And then the x value was negative 2. That's this piece, so that's where the negative 2 is coming from. So to find the final answer to my my definite integral, we would have 2 to the 8th over 8 plus 2k minus negative 2 to the 8th, because it's an even power, it's the same as 2 to the 8th. Cancels the negative, and then minus 2k. So subtracting would cancel this. I get 2k, distribute the negative again, plus 2k is the answer to the definite integral. But remember, the definite integral is equal to 16, so is this. This is equal to 16, so 4k equals 16, k equals 4. And there were other ways to do the same exact problem. You actually could have broken it up. You could have done the integral from negative 2 to 2 of just x to the 7th, plus the integral from negative 2 to 2 of just k equals 16. So, sorry that my pen is bleeding. And in this case, you could have really remembered that this is the same thing as a rectangle whose height is k, and whose width is from negative 2 to positive 2, so 4. And that actually could have gotten you the integral of the constant again. And then this, you would do your antiderivative as before. All right, number 6. Absolute value. I say this every single time we do an absolute value. I tell you that you cannot calculate with an absolute value. What I mean is you have no way of algebraically doing the derivative of an absolute value, and you have no way of algebraically doing an integral of an absolute value, because you don't know the derivative of an absolute value function, nor can you do the antiderivative of an absolute value function. I say that every single time. So what you're supposed to do when you see your absolute value functions is to graph it. And yes, we have done that every single time you've dealt with the absolute value function. If you remember, which most of you did not, on Thursday, the day before you took your quiz, I said that statement out loud in class. I said that your absolute value function cannot be integrated, so you always graph absolute values. So for this graph, it's the absolute value shifted to the right one. And if you did not know that, then you would just go through and substitute in values. If you substitute in 1, you get 0. Substitute in 0, you get positive 1. Substitute in 2, you get positive 1. Substitute in 3, you get positive 2. So now you can see that you have your absolute value graph. You're going to be asked to do the net signed area from 0 to 3. This is area would be 1/2 times 1 times 1. And then this guy, the area would be 1/2 times 2 times 2. So this area is 2, this area is 1/2, and together we end up with 5/2. Add those two areas together, and we get 5/2. All right, number 7. So the integral of this piece we know. So let's take the question. So again, we always say start with the question. I know that if this wasn't here, the answer would be a plus 2b. So since I know that, I'm going to split it up so it's acting as if it's not there. Just like derivatives, you can split up integrals if they're added or subtracted. So now, this is the given information, which was a plus 2b. There's two ways to do it. You could say that that's a function from a to b of the function 5. Net signed area would be a rectangle with a height of 5 and a width of b minus a. Other way, antiderivative would be 5x. F of b would be 5b. F of a would be 5a. Therefore, you would have 5b minus 5a. So I'm going to put that in. Plus 5b minus 5a. And then your a's, it looks like we have negative 4a, and your b's, you have 7b's. Let's see. Number 8, we did the same exact question in class, just a different function. Find the displacement. So, two definitions for displacement. You have the definition of s of b minus s of a, but we don't have the position function, so I don't want to do that. You also have the definition, the integral of velocity gives you displacement. So for this problem, both would be correct. This one is easier to use because you have velocity. So I'm going to rewrite this from 0 to 4 of 3t squared minus 6t minus 9 dt. Antiderivative would be t cubed minus 3t squared minus 9t. F of 4 would be 16 times 4 is 64 minus 16 negative 48 minus 36. So we end up with f of 4 is equal to negative 20. F of 0, though, easy one, is 0. So this problem says that I would find f of 4 minus f of 0. Therefore, my displacement is negative 20. And in this case, it is measured in feet. All right, letter B. Find the total distance traveled. So this one's a little bit harder. Total distance says I take the velocity and set it equal to 0, which are finding my x-intercept. So I'm actually going to factor this out as I write it. My factors then become t minus 3 and t plus 1, t equals 3, and t equals negative 1. We're doing from 0 to 4. Negative time doesn't make sense. So here's my quick little sign chart. Here's 3. The velocity at 3 is 0. The velocity before 3, so 2, would be negative. The velocity after 3, any number after 3, becomes positive. So to find my total distance, I would take alright, so I'm going to take the integral from 0 to 3 is negative, so I'm going to subtract the negative integral. That's how you do total distance. And then you add the positive integrals to find total distance. So the antiderivative, I'm going to do that up in the right-hand corner. The antiderivative of velocity would be, I think I had it already. The antiderivative is t cubed minus 3t squared minus 9t. F of 3, f of 4. Those are the values that we need. I believe we found f of 4 before. F of 4 was negative 20. And so I just have to find f of 3. F of 3 would be 27 minus 27. Wow, that's odd. Minus 27. So I get negative 27. All right, let's see if this makes sense. So, negative f of 3 is negative 27 minus 0, because that's f of 0, plus the integral of f of 4 minus f of 3, which is negative 27. So, things to help you double check your answer. Because this integral here has a negative in front, then the inside here should be a negative value, which I do get negative 27. In here, because I'm adding that integral for total distance, the value I get should be positive, and I do. I get a positive 7. The answer then becomes positive 34 feet. So total distance by hand is add your positive integrals, subtract your negative integrals. And your integrals depend upon, in this case for total distance, velocity. Okay? And then letter C. What would I write in the calculator? So two different things. You would do fn int, absolute value of the velocity function, or y1, I would accept, comma, x, comma, from 0 to 4. So that's the older calculators. The newer calculator is kind of nice. You get x equal to 0 to 4, absolute value of the function, in this case it's velocity, or y1 I would accept, and then dx. So last one, your bonus. We have a bunch of areas given from 0 to 10. The graph of f prime. Here I have an initial value. What's the maximum value on f? So I'm trying to find the max on f, which means I would have to do f prime sign chart, which I can easily do right here because this is the graph of f prime. F prime sign chart is, if I have f prime and I want f prime sign chart, I'm doing y values. So the y value at 0 is 0, the y value here is 0, the y value here is 0, and the y value at 10 is 0. Then the y values are positive, y values are negative in between, y values are positive. So, what is the maximum value? Well, maximums happen when your sign chart changes from plus to minus, so there's a max. Maximums also happen at endpoints if you're decreasing before. So this is also a max. So my issue of finding the absolute max would be that I have to compare f of, let's call this point right here A, and I have to compare it to f of 10. So we're doing plain old integrals. So that would be the same as saying, given an initial value, which I think they gave me, f of 0, then to find f of a, I would take the integral from 0, oopsie, that's supposed to say 0, to the value a of the function's graph right there. So f of, I don't know, f prime of dx, let's say. And this one, same thing. I would do the initial value plus the integral. And let me do that in a different color so you don't get confused. F of 0 plus the integral from 0 to 10 of f prime dx. So then the question is, we know f of 0 is 2, so we just have to find these integrals. So this first integral here, the integral from 0 to a. So that would be the net signed area of the shaded piece 20, And then there's no more to deal with, so that value here would be f of 0. And I'm running out of space, but I'll squeeze it in. F of 0 is 2, and then plus the net signed area of 20, so we get 22 for f of a. F of 10 would be the net signed area from 0 to 10. So I'm going to actually do this backwards. F of 0 was 2 plus the integral is what I'm going to put in here. So the net signed area would be the positive 20 because it's above the x-axis, the negative 6 because it's below the x-axis, and then the positive 4 because it's above the x-axis. So we get that value here becomes, 18 plus 2, which makes 20. We're looking for a maximum. 22 is greater than 20, therefore the answer is 22. And that actually happened on the interior point at A. So there are all the multiple choice problems from your quiz.